What's the difference between enthalpy and heat? When we talk about the phases a molecule can exist in, solid, liquid, gas, or sometimes plasma, we're talking about a relationship of temperature and pressure. From the last video, we understand the relationship of heat to temperature, but what's the difference between enthalpy and heat? Because of the direct relationship with temperature and heat, when you increase the temperature in a system, you assume that you're increasing the amount of heat that's in the system, and you also assume that you're going to eventually change the phase. However, if we increase or decrease the amount of pressure that those molecules are experiencing in a given system, we're going to change the phase of the molecules themselves as well. So you could also argue that phase diagrams will change based on the pressure, irrespective of the temperature. To be able to talk about heat transfers regardless of the amount of pressure, aka regardless of the phase of the molecules, scientists came up with something called enthalpy. And for the most part, we know the phase that we're talking about, so we can assume that the change in enthalpy is equal to the change in heat. When we know the pressure, enthalpy and heat are similar. When we do not know the pressure, enthalpy is different than heat because it is dependent on the phase of the molecule. The more energy that molecules are able to absorb, the more they start moving around. And the more they start moving around, the less we're able to say where they specifically are. You're never able to say where a molecule exists and the direction that it's moving at the same time. You can say one or you can say the other. The more uncertain you get about being able to say where a molecule is, the more disorder or the more options it's got, the more entropy a molecule has. That is also a relationship of increased energy, and that increases the disorder of the system. This disorder is also going to come about if you have one really big molecule that gets broken into two smaller molecules. Two molecules are able to move about a lot more than one big molecule is able to move, and this has a lot more disorder than this does. So breaking bonds also increases the disorder or increases the entropy of a system. We cannot change heat and temperature at the same time, so we talk about changes in entropy as changes in heat over a specific temperature. If the temperature changes, the entire entropy is going to change of the system, but we cannot talk about changes in heat and changes in temperature. Changes in entropy has to deal with changes in heat at a specific temperature. But what about the leftover energy? We know that overall the energy in the universe is going to be conserved, but not all of that energy is going to go directly to the molecules. Like, won't some just be free? Yes. In order to calculate how much free energy is left in a system, delta G is equal to delta H, which is the enthalpy of the system, or most commonly, the amount of heat that is changed when a chemical reaction occurs, minus temperature times a change in entropy, or minus T delta S. Delta G equals delta H minus T delta S.